Alright, hell yeah. So I have never done this method of u substitution before. And then even getting started, I was just like, well, we can actually get this inside the square root, because we can say that x is just square root of x, square root of x, and this is the square root of x. So it's the product of three things. We can bring everything inside the square root. We're going to have two x's in here, and then this, so it's going to be x cubed plus 3x squared. And maybe that's the next problem I'm going to do just to double check, and we'll see how fast we do this. But u substitution says we're going to choose a u, but when we take the derivative of that, the derivative is just going to be 1, and that's not going to cancel this term out here. And so, but let's do it. So we're going to have our u is going to be x plus 6. So now, anytime that you choose a u, I just like to at least start writing it in. So I'm going to go integral of x, square root of u, and then dx. We're going to do one step farther. I'm going to go the integral of x. I'm going to say u. This is u to the 1/2. It's easier for me to see the power rules, when that time comes. Okay, hell yeah. But we're still going to take the derivative of u with respect to x. I like to use hella parentheses, so I'm going to take the derivative of x plus 6 and then the derivative of x. I don't know, just it helps me out a little bit. Anyway, the derivative of this, and you could even the rules of derivatives are if you have a plus or minus. This is the derivative of x dx plus the derivative of 6 dx. And even this, you can use the constant rule. This is 6, the derivative of 1 dx. And I think it's really fascinating. Doing this at the simplest level, and I can get faster at saying this. This is your function. And what's a constant? Well, here's 1, you know what I mean? And then here's a line. And so this is a y equals mx plus b. Guess what your slope is? 0. So this is a y equals 0x plus y-intercept of 1, 1. So hell yeah. Now this is your equation. You could substitute this as a derivative of 0x plus 1 dx. And that goes a huge long way to be like, well, what are we talking about? What we're saying is that this is our independent variable. 0, 1, 2, 3. As we're changing this, let's say we just change it 1, 0 to 1. What happens to our function? Our function goes to 1 to 1. And so the change in the function is 1 minus 1. The change in x is 1 minus 0. And we have 0 over 1. We have no change. Derivative of a constant 0. So hell yeah, I like doing stuff like that. And then the derivative, we already said, this is 1. And that's a good way to show that. How would this be? Well, this is your function. You have a function of x, y is equal to x. You're going to change x. So we're going to go change x from 0 to 1. The function goes from 0 to 1. So we're going to have 1 minus 0 divided by 1 minus 0. And linear functions, even if you do an average for your derivative over a period, like what we just did was change in the function, change in x, and hell yeah, we get 1. Cool. Okay, so hell yeah. So yeah, the derivative's 1. So we have du dx is equal to 1. U substitution, I like to think of this as an equation of 3 terms. We found the first one. Let's solve for dx. Dx goes upstairs, the 1 comes downstairs. That's du divided by 1, which is just du. Let's solve for du. du is equal to just 1 times dx. Alright, hell yeah. So there's the 3 things. And this is the one we're going to use. We're going to see that we have a dx here, and we're going to sub this in. So that's the next thing we can do. So we're going to do x u to the 1/2, and then we just have this du term. But still, what do we do with this term? That's where we're just like, well, what equation has u? What equation has x in it and a u in it? What equation can we get x as a function of u? And it's right here. This equation you could write as u as a function of x is equal to x. And this is where I like to use these parentheses to be like, oh, there's the changing variable. And so we could solve this for x. And we're going to say x is equal to u minus 6. And then write this as an equation. This is x as a function of u is equal to u minus x. But anyway, we solved for x, and that's all we have to do is put that in there. So we have the integral of u minus 6, u to the 1/2 du. And now what do? Well, we can, FOIL this in. And so we're going to have u to the 3/2 minus 6u to the 1/2. And we're going to take the integral of the entire thing du. Okay, hell yeah. And I don't mind using lots of paper on this. And so we're going to go u to the 3/2 minus 6u to the 1/2 du. I'll write it sloppy because what we can do is say this is the integral of u to the 3/2 du minus, I'm going to bring out the 6, integral of u to the 1/2 du. So that's one of the rules of integration, is the integration of 1, is you can set up multiple integrals. So we just use power rule on this. That says that we're going to say u to the 3/2 plus 1 divided by 3/2 plus 1. 3/2 plus 1 is 3/2 plus 2 2s, 2 over 2, which is 5/2. So this is, I'm just going to, once I get to a place, we'll be like, well, I actually want to rewrite this. So I'm just going to go u to the 5/2 divided by 5/2. And I was like, well, I really want to rewrite this. This is just the reciprocal. So let's say this is 2/5 u to the 5/2. That was this one. And then this one is going to be -6. This power is going to be u to the 1/2 plus 1 divided by 1/2 plus 1. That's going to be 3/2 divided by 3/2. If this is 3/2 divided by 3/2, it's going to be reciprocal 2/3. So I'm going to have -6 times 2/3, and this is a multiple. So that's going to be -12 divided by 3 is -4. So that's the constant out here, minus 4. And then we have u to the 3/2 plus a constant. So we're done. And now we want to check this. You know what I mean? So we have, this was our integral. And maybe we can write it down just on a little card so we can reference it. So we have x square root of x plus 6 dx. And I didn't even sub in what u was. What did we say u was? U was x plus 6. So heck yeah. So we're going to say this is 2/5 x plus 6 to the 5/2 minus 4 x plus 6 to the 3/2 plus a constant. Sorry about that. Okay, now we're going to double check this one using differentiation. So I'm going to take the derivative with respect to x, and I'm just going to say of all that. We have a plus or a minus sign here. We got a minus sign. So I can take the derivative of the first minus the derivative of the second. Hell yeah. We have constants out here. So I can say this is 2/5 times the derivative of that minus 4 times the derivative of that. Okay, hell yeah. I don't know what the derivative of this to a power is, but I do know what, u to the 5/2. I do know the integral of that du. I do know the integral of x to the 5/2 dx. And those would be the same things going on. But when we do u substitution, we have to, what do we have to do? Well, this is differentiation. And so we have the constants outside. That's a rule of differentiation. But let's say we do u substitution for this. U is going to be 6 plus x for both of them. So let's write this out. We're going to take the derivative. I can just write this in. So it's x plus 6 to the 5/2, and then we have x plus 6 to the 3/2. Okay, so I still have this 2/5 out here, but I want to take the derivative, and I want to say u is x plus 6. So I want to take the derivative of u to the 5/2 dx. But I can't do that because this isn't an x. But I can do this. I can take the derivative with respect to u and then come over here, du dx. And so here's the chain rule. And always do this. Like once you set up the chain rule, cross out these two. And then put back your u. This is the derivative of x plus 6 to the 5 halves with respect to x. So the fact that, you know, those two cancel, and so that's kind of cool. So I do need to, this is its own term, so we need to take the derivative of u with respect to x. Sometimes you have to use the chain rule again. This one's straightforward, and this is just 1. And so, cool, I'm just going to say that's 1 and we can be done with it. And then this is, I'm going to have a constant, but now I'm going to, the derivative of power is bring down the power. So I'm going to do 5 halves. Take this to the 5 halves minus 1. 5 halves minus 1, that's 3 halves. Cool. And then we already did the du, you know, that's multiplied by 1. And then those cancel. So, and then this is u to the 3 halves. And then we just put back our u. So we have x plus 6 to the 3 halves. And is that what we had? This is x plus 6 to the 3 halves. I feel like we've, oh, you know what? That was just for this term. Okay, so now that was that term, and now we have to move on to this term. So now we have minus 4. I'm going to the same u substitution, but we're going to have the derivative of u to the 3 halves du, and then du dx. Same thing. I want to take the derivative of this, but I just don't know how. But if I put this as u, hey, I know how to take the derivative of an exponent. And again, cover these up. This is the derivative of x plus 6 to the 3 halves. That's when you put the u of x plus 6 with respect to dx. So that is the answer for this. And so let's set it up. Du dx is still 1 in this case. And then same thing. We're going to bring down the power. 3 halves. U to the drop it by 1, that's just 1 half. Hell yeah. And then multiply by 1, we're done. And so this is 4 divided by 2. That's going to be 2. We're going to have negative 6. So we're going to have negative 6 u to the half, which is negative 6 x plus 6 to the 1 half. And cool. And so now we have x plus 6 to the 3 halves minus 6 x plus 6 to the 1 half. It still doesn't look like our original thing, but let's work it out. This can be broken up into x plus 6 to the 1 power and then x plus 6 to the half power. This is minus 6. I'm just going to say plus a negative, I don't know, plus a negative 6 and then x plus 6 to the half power. It's actually these two terms that are the same and these two terms that are different. So now I can put these, I'm going to FOIL them to this direction so we can just do it in one step. X plus 6. That's what these two terms are. And these terms are x plus 6 minus 6. And there you go. So now we have x square root of x plus 6. And hell yeah. And we did it. And that was under 20 minutes. And so that was pretty sweet.